Hello and welcome to Shridevi Classes YouTube channel where we inculcate interest and understanding of class 12th physics that will remove all sort of confusions and improve your scoring ability in any examination. Today in our chapter electrostatics, we will discuss two fundamental characteristics of charge, that is conservation of charge and quantization of charge. Let's start. Electrostatics is a study of those electric phenomena which are produced by a stationary charge. That means source charge is stationary in position and field effect surrounding it is called as electrostatics. In fact, if a charge is in motion, it also produces an electric field, but that electric field is very complex and beyond our subject understanding limit. And if a charge is moving with a constant velocity, it also produces a steady magnetic field surrounding it as shown by this brown circle here. And if this charge is moving with an acceleration or deceleration, that means with varying velocity, then it will produce a time varying magnetic field. And we have to study magnetic effect of moving charge in some other chapters. Electrostatics is electric effect of charges. Let's explain how charge on material body comes in picture. All material body are made of atoms, and atom has nucleus having proton and neutron and orbital electrons. Number and charge of proton in nucleus and number and charge of orbital electrons is equal and opposite in nature. So inherently atom as well as material body is charge wise neutral, and in all material bodies charges are produced by transfer of orbital electron. When a body acquire additional electron, it become negatively charged, and when a atom or body lose orbital electron, it become a positively charged body. All charged body possess mass. No charge can exist without mass, and electron also have a little mass. When a negatively charged body acquire electron, it also acquire mass of those electrons. So in comparison to a neutral body, in a negatively charged body, due to increase in electron number, there would be a small increase in mass equal to mass of those additional electrons. Similarly, in case of positively charged body, when it loses electrons, the positive charged body would have a little decrease of mass equal to the mass of those electron released from the body. We have seen that electric charges are produced by shift of orbital electrons. Now these electric charge has some fundamental properties, and one such property is electric charge is additive. That means total charge of any body is the algebraic sum of different charges on it. That means if a body got plus 2q amount of charge, and if plus 3q unit charge is also added to it, then the total charge will add up to plus 5q charge. Now here both positive charge are deficiency of electron, and total deficiency of electron will be added up. Similarly, if I got a body of plus 2q unit charge and there is another charged body minus 3q unit charge, and if they are added together, then their addition will become only minus q unit charge, as minus 3q is surplus of electrons and plus 2q is deficit of electrons, and when deficiency and surplus is added together, some electronic charges deficiency and surplus is neutralized, and the net result is some surplus of electronic charge, but it is not earlier higher magnitude, it is the numeric difference of these two. So we can say that electric charge got algebraic additive property. Another fundamental property of charge is quantization. When a physical property exists in discrete packets and not in a continuous manner, it is called quantized. So charge is quantized. Electric charge is not a continuous flow like a liquid type quantity, but it has discrete steps packet value. Millikan in his famous oil drop experiment in the year 1911 observed that charges of any nature, whether it is positive or negative, exist only as integer multiple of one minimum discrete amount, that is electronic charge, and numerically it is 1.6 into 10 to the power minus 19 coulomb. Millikan has used a nozzle and made a spray of oil, and by friction oil drops get charged, and when charged oil drops are passed through a uniform electric field and motion is studied and analysis is done, it is found that all charges which exist there are only integer multiple of one minimum charge amount, that is 1.6 into 10 to the power minus 19 coulomb. So we can say charge less than this minimum quantity is not possible. So 1.2 into 10 to the power minus 19 coulomb is not possible type of charge. Similarly, if minimum charge is 1.6 into 10 to the power minus 19, the next higher would be 2 times or 3 times or 4 times of it. So non-integer multiple of electronic charge like 4 into 10 to the power minus 19 coulomb charge is not possible. Quantization is a concept of microscopic level, and it is applicable to very fine microatomic level interactions. In fact, the quantum of charge, the minimum amount of charge, is so small that the practical large scale charge phenomena can be regarded as continuous fluid like flow. Say for example, if there is a current of 1 ampere flowing in a wire, it means 1 coulomb charge is flowing per second, and 1 coulomb means 1 electron got 1.6 into 10 to the power minus 19 coulomb charge, and 1 coulomb means there would be 6.25 into 10 to the power plus 18 number of electrons which are moving per second. So in such a huge number, few numbers 1, 2, 3 won't have any meanings, and we could say that charge in practical life is some sort of continuous fluid like flow. Another important and fundamental property of charge is conservation of charge. Electric charge is conserved. That means the net or the total amount of charge in an isolated electric system is always constant and remains the same. In other words, we can say that in any process, if our charge is created or destroyed, it will always be in equal and opposite amounts. That means equal amount of positive charge and equal amount of negative charge is created or destroyed together. One can't create or destroy charge. It can only be transferred from one part to other. Conservation of charge is a fundamental and universal property. Law of conservation of charge is applicable to all conditions and everywhere, whether it is electrolysis, chemical reactions, radioactivity, nuclear reaction, or any physical change, without any exception in our universe. Say for example, in a radioactive decay, radioisotope of uranium-238 decay and fragment into and emit alpha particle, a nucleus of helium, with thorium-234. Now if you study nuclear charges, then before decay uranium-238 has 92 protonic charge, and after decay the 2 composite nucleus has 90 plus 2 unit of positive charge. So charge before decay and after decay remains the same. Similarly, in ionization process, common salt NaCl dissociate in water as positive ion of sodium and negative ion of chloride, and if you see before ionization, NaCl is charge wise neutral substance, and after ionization positive 1 unit charge and negative 1 unit charge added together become 0. So charge before ionization and after ionization remains the same. Another wonderful example of charge conservation is pair production. When a gamma photon having energy more than 1.02 MeV, here 1.02 MeV is sum of rest mass energy of electron and positron. As per Einstein famous relation E is equal to mc square, mass is a condensed form of energy, and we can produce energy from mass, or we can also create mass from energy. So to create mass of one electron or positron, the energy required is 0.51 MeV, and for pair the total amount of energy required is 1.02 MeV. So if a gamma photon got an energy 1.02 MeV or more, it will produce 2 mass particle. One is electron and second one is positron. Both have identical mass, identical charge, but of opposite polarity. Gamma photon is a charge wise neutral entity, and after this pair production the resultant charge of one electron negative and one electron positive total is again 0. So charge before pair production and after pair production would be the same. Here if gamma photon got an energy more than 1.02 MeV, then 1.02 MeV energy would be used to produce mass, and the remaining energy will be distributed among these 2 particles as kinetic energy of motion. Another example of charge conservation is photoelectric effect, and if photon of less than pair production energy such as X-rays, ultraviolet or visible falls on a metal body. The photon energy is used to remove electrons from metal surface if photon energy is more than work function. And in this photoelectric process, when electrons are removed from metal body, this metal body will become positively charged, and if we place this body in an electric field, we found that this metal body having photoelectric effect will experience a force in the direction of electric field as positive charged body. With this learning video, now you understand what is conservation and quantization of charge. Our other learning video of the same playlist will enhance your interest and understanding in physics. If you like our study material, do share it with your friends. And if you want to get these study notes and join our online classes, do join our membership. Have nice time. Thank you very much.